Today I'll be finding the integral of sine of x without using the fundamental theorem of calculus. Or like, I'm not going to just say this is negative cos of x because integrals are antiderivatives. Instead, I'm going to use another way to prove that sine x, the integral of sine of x is negative cos of x. Alright, so let me just write a diagram here. Sine of x would be something like this. It goes down and so forth. So again, my method is to split this up into multiple rectangles, and then we get something like this. The integral of sine of x dx from, let's say, 0 to x. So let's say here's x. X is our stopping value. Alright. Would equal, let's say each interval we move by would be h, or it would actually be dx, but I just like to use h, alright? So lim as h approaches 0. So the first rectangle right here would have a height of sine of h and a base of h. So the second rectangle would have a height of sine 2h and a base of h. So it would be right here. This rectangle would have a height of sine of 3h because its position is x equal 3h. So x equal 3h, then its height would obviously be sine of 3h. So, and then, let me just dot here, plus our final height would be sine of x, and its base would be still be h, so h sine of x. All right, and now I want to bring your attention to the cos addition identities. So cos alpha plus beta equals cos alpha cos beta minus sine alpha, sine beta, and cos alpha minus beta equals cos alpha cos beta plus sine alpha sine beta. All right, and furthermore, I want to subtract these two. So cos alpha plus beta minus cos alpha minus beta, and you'll see that this is a telescoping, I'm trying to use a telescoping series, equals negative 2 sine alpha sine beta. Because when we subtract these two, these cancel out and these sum together to get a negative sum. And I'm going to simplify this furthermore by saying negative sine alpha sine beta equals 2 cos alpha plus beta minus cos alpha minus beta. Alright. Now, I want to look at this integral. I'm going to multiply negative sine of h to it. So negative sine of h here from 0 to x, sine of x dx. And then I'm going to ignore the limit because that'd be tedious. I'm going to factor out h, and then I'm going to multiply negative sine of h to the front here. Or I'm just put the negative in the front. So it would look something like this. 2h sine h dot negative sine of h sine of x, and yeah, I'm running out of space. Alright, so we have this integral. Now, we can use this formula and convert it into cos. And then we get a telescoping series, as you'll see. So I'm going to ignore this part here. I'm going to say equal to, well, negative sine of h times h, where this is alpha, or no, yeah, where this is alpha, this is beta. This would be cos 2h minus cos 0, because h minus h is 0. So cos 2h minus cos 0 over 2. Let's look at the next one. Alpha would be 2h, beta would be h, so it would be cos 3h, and then alpha minus beta would be 2h minus h, and then we get h. So cos 3h minus cos h. And look how this negative sign gets canceled out when we convert it to cos form. So cos 3h minus cos h, 2. And hopefully you notice the pattern here. The next one would be cos 4h minus cos 2h over 2. And I'll just do one more. Cos 5h minus cos 3h over 2. And I want you to see here that this negative 3h and 3h, they cancel out. 2h and 2h, they cancel out, and so forth. The only things that don't get canceled out is this and this. So we have, so let's combine them. They all have the same denominator. So negative and 2 more terms don't get canceled out, and I'll show you what they are in a little bit. And then those 2 terms are plus cos x plus h plus cos x over 2. And that's what this telescoping series end up to be. Hopefully you should know why cos x plus h and cos x don't get canceled out. It's because this telescoping series leaves at the end, or leaves at the beginning, 2 terms that are untouched. So you can see by argument of symmetry that the last 2 terms would be untouched too. So the 2 smallest terms and the 2 biggest terms are the terms that will be untouched by this telescoping series. And it would be tedious to write it out here, so maybe you can find this out for yourself, that cos x plus h and cos x are preserved. Okay, now we have this. Now we can take the limit as h approaches to 0, and then we get equal negative 2 cos 0, because h becomes 0, and plus 2 cos x. Wait, I might have done something wrong here. Oh, never mind, I didn't do anything wrong. Right. Oh, rip. So basically I ignored the h here. So we'll deal with the h later, but yeah, this is a mistake on my part. Over 2 equals negative cos, or let me just simplify it. Just cos x minus 1. Cos 0 is 1, divided by 2, you get negative 1, and then 2 cos x divided by 2 is just cos x. Remember, this cos x minus 1 is only in the inner part. We still have not considered this negative sin h and h here. So let's do this. Equal negative h sine over h, sine x dx. And like we said, this telescoping series here just telescopes down to cos x minus 1. And from your limit identities, you know that as the limit as h approaches 0, this just becomes 1. H over sine h just becomes 1. And since there's a negative in front of it, it would become negative 1. So 0x sine x dx equals negative cos x minus 1 equal 1 minus cos x. And that's the integral from 0 to x of sine x dx. You might be confused as why there's a 1. That's because, let's look at the graph here. So when cos equals 0, the area under the curve equals 0. So when cos x, or when x equals 0, x equals 0, cos equal 1, 1 minus 1 is 0, area is 0. And that makes sense, because when we're here, the area is actually 0, right? That should make sense. And then when cos of x equals pi over 2, then cos becomes 0 and the area is 1. And that should also make sense, because when it's pi over 2, it's here, and all this area is 1. So that's where the 1 minus cos x comes from. And yeah, I hope that's been helpful, and thank you.